This lesson will be about finding unit rates with complex fractions. What is a unit rate? A unit rate is a rate expressed as a quantity of 1. You are probably more familiar with unit rates than you believe. Think of miles per hour when you're traveling in a car. Think of a student per teacher ratio, how many students would be assigned to one teacher on average in a school. Cost per unit, like how much does one pencil cost if you can buy a pack of pencils for $2.25? Or how much is an ounce of cereal if you can buy 26 ounces for $3.99? So cost per unit, and the unit could be anything. It could be a toilet paper roll, it could be pencils, it could be anything that you could buy, but you want to strip it down to how much does one of the item cost. And it could be one in a measurement of weight, or it could be one actual item, like how much does one hot dog cost in a pack of 8 hot dogs. We are going to use proportions to help us solve. Now, you've worked with proportions in 6th grade. So an example would be he can run 5 laps in 28 minutes. How long is it going to take him to run 1 lap? So what's key is you keep in mind what your categories are, because when you set up a proportion, it's really important that if you're going to do red marbles over green marbles for one ratio, then the other ratio is red marbles over green marbles. So whatever your categories are, it could be money in a category, it could be distance in a category, but you want to have some kind of relationship between the categories vertically and horizontally. So here's what a proportion looks like. A proportion is a statement that 2 ratios are equivalent, so you have a ratio on the left side and a ratio on the right side. My categories in this problem are laps and minutes. So I've decided to make the numerator on the left side laps. 5 laps in 28 minutes. So that's a ratio, and those are related because they're both from the same scenario. 5 laps in 28 minutes. I have laps over minutes. Now I've set the standard for my second ratio. I again need to have laps over minutes. So I'm looking for how long. I don't have the minutes, but I know I want to have 1 lap. That's why I've matched a 1 on that numerator, and I'll put an unknown, a variable, in the denominator. Now we'll cross multiply. So 5 times x is 5x, and that's going to equal the cross product. 28 times 1 is 28. Every proportion you have, the cross products will always be equal, so we can use that fact to help us solve for any unknowns. So we're going to divide both sides by 5, and we're going to find that the answer is 5.6 minutes per lap. So the MPL, I'm just using a way to keep myself, help to remind myself what my categories were. So 5.6 minutes per lap. Okay, complex fractions have a fraction in the numerator or the denominator or both. It looks like this. Now we simply read that as 1/2 divided by 3/4. If you had to work it out without a calculator, and this is pulled out, this is not a proportion, this is a complex fraction, but if you had to divide this by hand, rewrite it in a way that you're familiar to seeing it. So 1/2 divided by 3/4. Probably most of you remember keep, change, flip. Keep the first fraction, change the division to multiplication, and flip the second fraction. Dividing by a fraction is the same as multiplying by its reciprocal. Now if you multiply, 1 times 4 is 4, and 2 times 3 is 6, and in lowest terms that would look like 2/3. So a complex fraction, just pretend those are any other numbers and handle them the same way that you would division. Now unit rate example, Sean mows half the yard in 1/3 of an hour. How long to mow the whole yard? So this is a unit rate in disguise. The whole yard can be considered 1. So my categories are the project, like the yard mowing, and the time. So I'm going to put 1/2 the yard on top, and I'm going to put the time on bottom, 1/3 of an hour. Now I've set a precedent, so my second ratio has to also be how much of the yard is mowed over time. And since I want to know how long to mow the whole yard, it's not a fractional part of the yard I want mowed, I want the whole yard mowed. I'm going to put a 1 on top. Now in the denominator, that's what I'm looking for, the time. So that's going to be my variable. Cross multiply. 1/2 times x is 1/2 x. And the only reason I write those little letters beside the 1/2 and the 1/3 is to help me remember what my categories are. Those are not variables that are going to carry through to the next stage of the problem. 1/2 x equals, now multiply 1/3 times 1, and that's 1/3. I need to get x isolated. So how do I move the 1/2? I'm going to divide by 1/2 on both sides, and my answer is going to be, if you don't have a calculator, 1/3 divided by 1/2 is really 1/3 times 2 over 1, and the answer is 2/3. And since it was in the measurement of time, I was looking for hours, so 2/3 of an hour to mow the whole yard. Okay, now here's where it gets very useful. If you find unit rates, especially if it has fractional components, it helps you to make a comparison. For instance, what if we knew Tom could hike 3/4 of a trail in 1.5 hours, and Ben can hike 2/3 of the trail in 1 1/4 hours? So it's hard to determine who hikes faster because it's different amounts of the trail and different times. But if I can make it become a unit rate for Tom and a unit rate for Ben, then we're going to know who hikes the fastest. So I'm going to set up a proportion for both of these, find the unit rate. So I have 3/4 of the trail for Tom in 1.5 hours. So I'm going to look for how many hours he can hike the whole trail. So then I can compare the times when I'm finished with Ben and Tom and see who hikes faster. So 3/4 of the trail in 1.5 hours, we're going to cross multiply. Okay, let's do Ben first. So 2/3 of the trail he can hike in 1 1/4 hour. So how long is it going to take him to hike the whole trail? Now let's cross multiply and start solving for Tom. 3/4 times x is 3/4 x. 1.5 times 1 is 1.5. Divide by 3/4. Cross multiply on the other side, so sorry. 2/3 times x is 2/3 x. 1 1/4 times 1 is 1 1/4. Now we're going to divide on both of these to see which one has the faster time. For Tom, divide both sides by 3/4. So he can hike the whole trail, one whole trail in 2 hours. And Ben, after we divide by 2/3, we see he can hike the trail in 1 875,000 hours, so his time is faster. He can hike the trail the quickest, so Ben is the faster hiker. Don't forget to match your units, your categories, whatever you want to call them. So if you've got miles over hours, your other ratio needs to be miles over hours. If you've got a project that you're doing like painting the house over minutes, then it's painting the house over minutes for your second ratio. Let me show you one more twist on a problem. Marge can bake 2.5 batches of cookies in 3/4 of an hour. So if I ask you to find the unit rate, a unit rate compares some category to 1. So do we want to know how long to bake one batch or how many batches for 1 hour? So you have two categories, and we could look at them both as a unit rate, and that's what we're going to do here. So we'll have two proportions to set up. Now the left side can be the same for both. The left side, I have my variable on the top. So it says in 1 hour, how many batches can I bake? My second one starts the same way, but this time I'm going to put a 1 in the numerator, which means I can bake one batch in how long, or how many hours does it take me to bake one batch. So it gives you a different look, still unit rate for both, so cross multiply, divide by 3/4, and you'll find out that the answer is 3 1/3 batches in 1 hour. Now for the second one, I'm going to find out how many hours to bake one batch. So cross multiply 2.5 x equals 3/4, divide by 2.5, and the final answer is going to be 3/10 of an hour to bake one batch. So look over this as many times as you need to. Go see your teacher if you need extra help. We'll all be happy to work with you. Go to tutoring. But the key ideas for unit rate with complex fractions are know your categories and be consistent when you set up your categories. And unit rate's all about per one or each one. So that's what you're solving for. Enjoy!